Hi Virgia, hope you're doing okay. As promised, we're going to go straight into the National 5 work. So what I'm going to do, I'm going to give a wee quick recap of what we've learned so far, and then we're going to get straight into the National 5 part of it. Okay, so as I'm doing this, if you can write down the notes in your jotter as well. Okay, so the good thing about it being on a video is you can pause it, you can take your time writing it down, but I do want you to get this into your jotter as well, please. Okay, so first things first, we have learned about 3 homologous series. Okay, so we'll write that first. We have learned about 3 homologous series. Okay, and the 3 that we've learned about are the alkanes, the alkenes, and the cycloalkanes. Now, first things first, with National 5, every sort of past paper that you do, every sort of question that you come across, you'll always get asked what the definition of a homologous series is. Okay, it's very important that we know the definition. Okay, so homologous series, it is a family of compounds that have the same general formula and similar chemical properties. Okay, general formula we'll come on to in just a wee bit, but what we mean by similar chemical properties is that they all behave the same way. Okay, so all the alkanes, they react the same way, all the alkenes, they'll react the same way, and the same with the cycloalkanes. Okay, so it's very important that we know the definition of a homologous series, because you do get asked it pretty much every single paper that you guys will do. Okay, now we're going to start with the alkanes. Before we do that, we need to talk about how we name our hydrocarbons. So first things first, the number of carbons determine the prefix for the hydrocarbon. And what we mean by that, okay, so if we put a wee sort of heading, number of carbons and we go for the prefix. Okay, so let's say the number of carbons is 1. Now the prefix for that, you should know, is meth. Okay, if it's 2 carbons, the prefix is eth. If it's 3 carbons, it's prop. If it's 4, it's bute. If it's 5, it's pent. If it's 6, it's hex. If it's 7, it's hept. And if it's 8, it is oct. Okay, just like an octagon has 8 sides, a pentagon has 5 sides. Okay, so that's how we determine what the prefix is for that. Now, this bit here you should also know, for all alkanes, the hydrocarbon ends in ane. Okay, so alkanes end in ane. So for an example, if we go for this alkane here, now you can see it's got 1, 2, 3 carbons. If we look at our table here, 3 carbons means the prefix is prop. Okay, and because it's an alkane, it ends in ane, this here is called propane. And that's how we get that. Okay? Right, now, if I put the wee sort of subheading alkanes. All alkanes contain only carbon to carbon single bonds. Okay, carbon to carbon single bonds. Now, you should also remember that carbon has a valency of 4. Okay, and it's got a valency of 4 because it's in group 4. Now, we did that when we did the atomic theory and bonding topic. I'm not going to go back into detail. We'll do that when we come back. However, you do need to know that carbon has a valency of 4, and what we mean by that is how many bonds it can form. Okay, so carbon has a valency of 4, so it can form 4 bonds. Now the next one, hydrogen, has a valency of 1. Again, that's because hydrogen is in group 1. So what that means, because it's got a valency of 1, hydrogens can form just 1 bond. So again, if we go for a wee example here, let's just go for 1 carbon. Now, if we go back to a table, the prefix for 1 carbon is meth. Okay, so we would call this methane. Now, carbon can have 4 bonds around it, so it goes 1, 2, 3, 4 bonds. Okay, and then around each bond is attached to 1 hydrogen. Okay, so that hydrogen, because it's got a valency of 1, can only form 1 bond. That hydrogen forms 1 bond. That hydrogen forms 1 bond. That hydrogen forms 1 bond. But the carbon forms 1, 2, 3, 4 bonds. Okay, if we go on to the next one with 2 carbons, and again, if we go back to our table, the prefix for 2 is eth. So we've got 2 carbons. Okay, now that carbon here already has 1 bond coming out it, so that means another 1, 2, 3 bonds can get attached to it. Okay, so it's now got 1, 2, 3, 4. The same goes with this carbon here. So that carbon has 1 bond there, so it can get 1, 2, 3, 4 bonds, and then each bond gets attached to a hydrogen. Okay, so because the prefix is eth, this hydrocarbon is ethane. And that's how we do that. Okay. Right, now, next part is the general formula. Okay, now the general formula is the formula that fits every molecule belonging to that homologous series. So for alkanes, the general formula, and again you should have done this as we were doing the National 4 stuff, the general formula for alkanes is CnH2n plus 2, okay, and N equals the number of carbons. So an example, if we bring that one down, okay, in this molecule here, methane, we've got 1 carbon, okay, so N equals 1. Okay, so if we sub that in, N, 1, H, and then this is the tricky part, okay, 2N, a number and a letter that are right next to each other with times, okay, so that would be 2 times 1, and then we add 2, so that becomes C1H, 2 times 1 is 2, add 2 is 4. Okay, now if you remember from atomic theory, if there's a 1, we sort of ignore it, okay, so that becomes CH4, and if you look at that molecule, there it is, 1C, 1, 2, 3, 4 hydrogens. Now this one here, again, if we look at ethane, N equals 2 because we've got 2 carbons. So if we apply that to our formula, that becomes C2, H, and then in brackets, 2 times 2 because N equals 2. Okay, so 2 times 2, add 1. Oh, sorry, add 2. Now, if we do that, yeah, that's C2, and then H, 2 times 2, that's 4. Add 2, that's 6. And there it is. Ethane has 2 carbons, and it's got 1, 2, 3, 4, 5, 6 hydrogens. That seems quite straightforward, okay. However, sometimes you can get asked to calculate the formula for an alkane with, let's go for, keep it nice and easy, 30 carbons. Now, there's no way in a sort of test or an exam or whatever you would be able to draw 30 carbons out and then draw the hydrogens in and then count them. So what we need to do, we need to use our general formula CnH2n plus 2. Okay, and it's so important that we remember the CnH2n plus 2 formula, and that is for all alkanes. For all alkanes. Okay, now N in this case equals 30 because we've got 30 carbons. So if we apply that, we've got C30, H, and then do our formula. Okay, so that's going to be 2 times 30, add 2. Okay, so that goes to C30, H, Now if we do this, 2 times 30, that's 60, and then add 2, we're getting 62. And that's it. Yeah, and that works for every single alkane you'll ever come across. Now, it can get a wee bit trickier, okay? It might ask you to calculate the formula of an alkane with let's go for 12 hydrogens. Okay, now N does not equal 12, and that's because N equals the number of carbons. Okay, we haven't been given the number of carbons, we've been given the number of hydrogens, so it makes it that just a wee bit harder. Now, what we do know is that H equals 2N plus 2. Okay, so the number of hydrogens is 2N plus 2, and we can see that if I sort of highlight that, in fact, wait there, I'll draw it again. Okay, so H equals 2N plus 2. Okay, now if we apply that, okay, we've got 12 hydrogens, so 12 equals 2N plus 2. Now, what we want N, okay, because that's the number of carbons. If we get the number of carbons, we'll know the formula. Okay, so what we need to do is to get the N on its own, we need to get the 2 that's multiplied to this side, and we need to get the 2 that's been added away as well. Okay, so what we do, we minus the 2. Okay, so we do the opposite of what it's doing, so we minus the 2. And you would have learned this in maths, what we do to one side of the equal sign, we have to do to the other side. So if we've minus 2 there, we need the minus 2 on the left hand side as well. And what happens, that now becomes 10 equals 2N. Okay? Now, we've got 2 times N here. So to get the N on its own, we need to divide by 2. Okay, so if we divide by 2 here, we need to divide by 2 on the left side as well. So 5, okay, because 10 divided by 2 is 5, and then 2N divided by 2 is just N. Okay, so N is 5. So our formula is C5H12. Okay, so that is question 4, and that's probably one of the hardest ones you'll get asked about that. Okay. Right. Just thinking what we need to do now. Right, I want you guys to do some questions now. Okay, that's almost 20 minutes, so if we do some questions. So question 1, I want you to draw fully I want you to draw butane. I want you to draw hexane, and I want you to draw octane. Okay, and then I want you to write the shortened structural formulae for butane, for hexane, and for octane. Okay, and what I mean by that, if we go for, in fact, let's go for propane. Okay, so if we go back to our table, it's propane, so we're looking for prop. Where's prop? There it is. So how many carbons do we have? We've got 3. Okay, so if we go back, propane has 3 carbons, so N equals 3. So if we draw that out, 1, 2, 3 carbons in a straight line, and then make sure every carbon has 4 bonds coming out it. Now that's so important, okay, so important. Now that is what we call the full structure, okay. The shortened structure, I need another pen. What we need to do is we need to draw a line between each carbon, okay, and then we write what we see. Okay, so to the left of the first red line we see 1 carbon, and then we see 3 hydrogens, so that becomes CH3. Okay, then we draw a wee bond, and then the next one we see 1 carbon with 2 hydrogens, so that becomes CH2. Now remember, because it's 1 carbon, we don't write C1, we ignore the 1, okay? And then our last one, what do we see? We see 1 carbon, and we see 1, 2, 3 hydrogens, so that becomes CH3, okay? Right. Right, I want us to go on to question 2. Let's go for this one. If you can do this without your notes, without looking back, I'd be very impressed. So, what is meant by the term homologous series? Okay, see if you can do that. Right. Question 3. Write the general formula for alkanes. Again, if you can do that without your notes, fair play. And then question 4, we'll stick to 4 questions. So 4A, write the formula for the alkane with, let's go for 9 carbons, let's go for 22 carbons, let's go for 4 hydrogen, and let's go for let's go for 28 hydrogens. Okay, so what you can do, you can pause this video because I'm just going to go straight on to the next part. Pause the video, see how you get on. After the lesson, I will post the answers up, so make sure you check them and you self-mark. Get into that habit of always self-marking your work. Right, next thing we're going to go into is something called branch chained alkanes. Okay, this is when it really starts to get into National 5. Okay. Now, SQA, they'll never sort of ask you a question about a alkane in a straight line. They'll give you a branch. Okay, and I'll describe what a branch is just now. Right. So, before we do that, I need to describe what a branch isn't. Okay, before we describe what a branch is. Now, if we call that, sorry, it's got 3 carbons, 1, 2, 3. If we look back on our sheet, we'll realise that the prefix for 3 carbons is prop, and because it's an alkane, it contains only carbon-to-carbon single bonds, it ends in ane, so that's propane. Okay. Now, if we label our carbons 1, 2, 3, okay, that's the longest chain we can get. 1, 2, 3. Now, if I draw that, okay, so what I've done is I have taken carbon 3 and I've put it to the top of carbon 2. Okay, now if we take the red pen and we label the carbons, the longest chain is still 1, 2, 3. Okay, so because the longest chain is still 3, that is still called propane. Okay, it hasn't changed. Now, if we draw four carbons, okay, and we get all our hydrogens in there, like so. Okay, we've got 4 carbons. Our longest chain goes 1, 2, 3, 4. Okay, so our longest chain is 4. If we go back to the previous sheet, we'll see that 4 has the prefix but, and because it's an alkane, it only contains carbon-to-carbon double bonds. That is butane. Okay, now what I can do, I can draw this here. Like that. So what I've done is I've taken carbon 4 and I've placed it on carbon 2, and I've put the hydrogen that was on carbon 2 onto carbon 3. Okay, now if we take a red pen and we label the longest chain, okay, the longest chain is 1, 2, 3. Okay, so instead of the longest chain being 4, the longest chain's now 3. And this here, because that's not a part of the longest chain, we call that a branch. Okay, we call that a branch. Now, I'm going to kind of wrap this up now. This here, this molecule here, we call 2-methyl propane. Okay, 2-methyl propane. And what, I'm not going to tell you why it's called that. I want you to go away and have a wee think, why is this molecule called 2-methyl propane? Okay, so that's your task. That's your task for next lesson. Okay, so make sure you're writing all this down. Make sure you're doing the questions, and to take away from today, you need to know what is meant by a homologous series. You need to know the general formula of an alkane. And you need to know how to use that, obviously. And finally, you need to memorize the prefix. Okay, so you should instantly know that pent means 5 carbons, hex means 6, meth means 1 carbon. So make sure you've got that drilled into your head. Okay, and I will post another video next lesson. Thank you.